Okay, so welcome to this presentation where we are going to focus on analyzing categorical data and more specifically how to run chi-square tests in SPSS. Just as a quick reminder, categorical variables, unlike continuous variables, really don't have a meaningful mean, right, or average. And so for that reason, we can't use t-tests or ANOVAs or other types of tests that are able to be run on continuous variables. Categorical variables require different types of calculations. And so also one of the great things about chi-square is that because we're not using continuous variables, there aren't that many assumptions. So we don't have to worry about whether or not our distribution is normally distributed. And also really the sort of main limitations of chi-square, or the main assumptions of chi-square, is that you'll need to have at least, expected frequencies of 5 or more per category, just because statistical power gets lost on small data sets and small sample subcategory sizes in chi-square tests. And then also, just like pretty much all tests that we run in statistics, we make the assumption about independence of data. So for chi-square to be significant, it's important that only one person can, or one observation belongs in one cell. So unlike, a paired sample t-test, we're assuming in chi-square that each observation is independent from one another. Okay, so for this example, let's use this research question here. So, does ownership of a digital device by Ethiopian students differ by gender? So, of course, ownership of a digital device is a categorical variable. Yes, no, I own a digital device or not. And then gender as well. So, again, to that independence of observation. So somebody cannot both own and not own a digital device, and somebody, at least for purposes of our data set, cannot be categorized as both male and female, right? So we will move on to testing out this research question in our data set in SPSS now. All right, here is my data set. And so just as a reminder, in my variable view, we're going to check out the variables we'll use. So first of all, here we go. I'm going to make this a little bit clearer for you. Device access right here owns a digital device. So that, of course, has values just confirming of 0 and 1. So yes, it's categorical. And then here's our gender variable, and we'll check here again. So male was coded 1, female coded 2. So both of those, again, are categorical. So yes, chi-square will be an appropriate test to determine whether or not these two variables are related. So what we do is we come up here, we go to Analyze, we go to Descriptive Statistics, and we go to Crosstabs. And I'm going to clear out. Oh, good. It's already cleared out. So as a reminder, we've done crosstabs before in this course, but now we're going to add in some statistics to see whether or not what we observe in our data set can be generalized to the population. So you're going to tell SPSS, how you want your variables to be displayed. So in this case, I'm going to put owns a digital device in the rows and then gender in the columns. But you can do either one. It doesn't really matter. It just is your preference as to how you want it displayed. So as opposed to just running it and hitting OK like we normally would do with a chi-square test, we're going to ask again a regular crosstab, we're going to ask SPSS to calculate our chi-square. So we go to statistics here. And here is our chi-square. So we check that box for sure. And then we can also, these variables that we're looking at here, gender and ownership of a digital device, are nominal, right? So you can also include these other statistics here, which are explained more in the field book. They basically confirm the chi-square result and maybe give a little bit of extra information like about effect size and, the level of the association between the variables. But really, the main thing is to make sure you check that chi-square box. So continue. And then, unlike, again, like the traditional crosstabs, you also want to go here to the cells box. And so I recommend making sure these percentage boxes are checked off, both row, column, as well as total, and then also the expected counts of your chi-square test. And the reason why you want to do that is that chi-square results the expected counts need to exceed certain values. I sort of mentioned that before. They need to be at least 5 or above. So that can help you confirm that sort of your test meets the assumptions of the chi-square. So that's my suggestion for checking. And so continue and then hit OK. Okay, let me explain the output here. So at the top, we have just our overall case processing summary, mostly just to show how many missing cases, right, and what the N was that was used for the analysis, in this case, 982. And that's important if we were hand calculating for sure, but we're not. And so let's look here first at our crosstab results. So as you can see here, SPSS gave us gender in the columns and ownership of digital device in the rows. Yours might be flipped around. The results will be the same. It's just, preference as to how you want to structure your analysis, your output. So, okay, how do we understand this? So first of all, as we can see here, owns a digital device? No. So this little section here under no are just the people in our data set who do not own a digital device. And we can see that 143 of them are men and 166 are female. So, and a total of 309 people in our data set do not own a digital device. So again, this expected count is for the chi-square test. So we'll get to that in a second, but it's fine, actually. There's no issues. If there was an issue with it, SPSS would tell us. But anyways, all right. So coming down here to interpret our percentages. Okay, so what does this mean? First of all, so it percent within owns digital device. So this is just telling us, okay, what percentage of those who do not have a digital device are male? It's 46%. And what percentage are females? 54%. So at least here it looks like females are a bit less likely, descriptively, not making any generalizations, in our data set to not own a digital device. And then you can also interpret separately percent within gender. That's how many males overall do not own digital devices. So that's 30.6%. Just looking here at number or percentage of males overall who do not own a digital device. And you can see the counterpart down here under yes, I own a digital device, percent within gender, 69%, right? 69% plus 30.6%, hopefully total 100%. So that's just within males. 31% of men do not own digital devices, while 69% do. And then over here at female, 54% do not own, oh, sorry, I'm at the wrong level. 32% of females do not own a digital device, while 67.8% do own a digital device. So that's how you can understand these percentages or interpret these percentages. Tells you a lot of information depending on what your research question is, right? Oh, and then the overall percent of total, that just tells us what percentage overall this cell represents. So males who do not own a digital device are 15% of our data set. Females who do not own a digital device are 17% of our data set. If we come down here to percent of total, and this is owns a digital device, in contrast, 33% of males who own a digital device are represented in our data set, and then our data set also includes 36% of females who own a digital device. So I know this gets a little bit like kind of wonky in the details, but it's actually really helpful information when you're trying to report out detailed sort of differences among groups, among nominal groups, among categorical groups. All right, but now we're going to go down to our chi-square test. Okay, so here is our overall result of our chi-square. And really all you need to care about here is the value in this top row, the Pearson chi-square. These other statistics I think I asked for, but in terms of what we need to report, sort of to our audiences and our research reports, and what sort of tells us the result of this test is really here in the first column. And so as we can see here, the chi-square value is 0.295, which is really low. I already know this. And then here's our p-value, 0.587. So we know we can't reject the null, that there are no significant differences between groups. And so we have to accept or not reject the null, not necessarily accept it, but not reject the null. And so we cannot conclude that there are any statistically significant differences according to our research question. So, and just as like kind of an example, or just to let you know, and maybe I'll try to run another example that shows some significant differences, because let's say this chi-square value was higher and the p-value was lower, and we could reject the null and there were significant differences. Where you can see here these little subscripts, A, those would be replaced with little stars associated with p-value and statistical significance. So as you can see here, each subscript shows that there's not significant differences in that sort of comparison. But if they were significantly different, you would see little stars there from SPSS. But then, of course, too, you would come down here and you would see, all right, overall, my chi-square, p-value would be also less than 0.05 in that case. But in this case, no statistically significant differences. And I asked for some extra statistics here, but really, those aren't that important. The most important basic one is the Pearson chi-square. These other statistics here, like the Kramer's V, the phi, the whatever, the lambda, those basically look at strengths of association between the variables, as well as sort of like predicting membership in categories. And in terms of the research question that we asked, we don't need that information. So again, when you are making conclusions about the differences between whether or not there are any differences between males and females in their ownership of digital devices, what you would look here to report would be your chi-square, and then you'd refer back to the crosstabs table to look at the actual values of those, how those two variables cross-tabulated. All right. Okay, so once you properly run your analysis in SPSS, you have to report it to your audience. And here's what we do, at least according to APA. Here's how we would write it up. Up top here, I've put the technical information you always need to include as according to APA. So this is the symbol for chi-square. Then you'll need to include your degrees of freedom, the sample size, always have n, but then you replace that with your sample size, and then equals the chi-square statistic, whatever SPSS calculated, and then finally what the p-value was. So again, this is really important in order to include this technical information, but just as importantly, you need to explain to your readers, many of whom maybe don't understand statistics very well, what it actually means in practice. So just saying our chi-square value was 0.295, therefore the test is not significant, that's okay, but it's helpful to explain a little bit more in depth as well in words. So here's what maybe you could report about this test. We performed a chi-square test to examine the relationship between gender and digital device ownership. Although our sample indicated that overall 67.8% of females owned a digital device compared to 69.4% of males, so there was a difference right in the sample, but the test results indicate that these differences are not significant. And then here exactly are our test statistic values. And again, this is important because if someone wanted to come through and hand calculate, they could, using the descriptive statistics you provide as well as these test results. They could check your work, even though no one really ever does. But it's important to include for transparency and sort of, rigor's sake. So then you would tell your readers, based on these results, we conclude that Ethiopian males and females are equally likely to own or not own a digital device. So that is an example of how to run a chi-square test, which again is to analyze whether or not significant differences exist for categorical variables, two categorical variables.